Can everybody hear me okay? Yep. Yeah, good. Thanks for bearing with us there. I chose, as it turns out, the wrong font for my presentation, which the computer didn't like so much here. So sorry about that. And thanks to everyone who's been holding out for this presentation since 10:30 this morning. So straight into it. The intention of this presentation is to be establish some base level knowledge in the area of biotransformation, which is principally to do with interactions between yeasts and hop compounds. So there's quite a bit of content in it. I'll try to sort of stop and ask for questions as we go, because I know otherwise it's pretty easy to forget. So yep, that's me. I'm, as I was already introduced, qualified in winemaking and science. Also qualified through the IBD in brewing too. And before taking the role with Lallemand as a technical sales manager based in Oceania, and I'm based in New Zealand. I was a production brewer for, probably the best part of 10 years in both New Zealand and the UK. So yeah, that's kind of where my background's coming from, and I've pitched this presentation in a way that I think it will incorporate science as well as practical aspects for brewers. Moving on, what is biotransformation? These are some of the things we're going to cover in the course of the presentation. What is biotransformation? Which bits should you be interested in as brewers? And why do yeasts transform some hop compounds? Additionally, we'll talk about the transformed compounds themselves, which are principally going to be talking about thiol and terpene compounds, and also promoting these characters in your beer. So, to begin, definitions. Biotransformation. We're defining this as chemical modification made by an organism on a chemical compound. Okay, and why is this useful? Well, I guess principally we're going to be dealing with the interactions between hops and yeast. Why? Gives us the ability to better utilize ingredients, to get more out of them, to create unique products, and also obtain better sensory intensity. So what we have, just as an example, here's some nice hops, and for instance, there are a couple of thiol-related compounds, one of which 3MH. I'm mostly going to use abbreviations because I don't expect everyone to remember actual compound names. There will not be a test later. 3MH, for instance, is a very sensory active thiol compound that smells and tastes like grapefruit. The esterified version smells and tastes like passion fruit, even more sensory active again. So largely what we're going to be looking at here is optimizing the release of these compounds through yeast activity from hops to better add complexity and intensity to your products. So there are a number of types of biotransformation. There is the freeing of bound compounds. There is transformation between groups, so for instance terpenes. There is also esterification of some of the above compounds, and de novo synthesis of esters as well, which we're kind of really only going to be concentrating on the top two, and that's going to be plenty of content as it is. And I guess just before we move on, brewers in the room. So a lot of biotransformation is kind of the modern beer styles that you would be looking for a lot of this in would be New England IPAs, hazy IPAs, things like that, where we're trying to get this really broad, juicy type hop character. And just brewers in the room, have you brewed IPAs? Hands up, IPAs, NEPAs, yeah, good, all right. Well, hopefully I'm not teaching you things you already know. But I guess the global context is, well in India, obviously, I've noticed wheat beers are king. And that's why it's interesting to tell you about something you probably don't know about quite so much. Globally, New England IPAs, hazy IPAs, this family of beer, rapidly growing market. Back home in New Zealand, easily in the craft segment, this is easily the biggest selling segment. It's a supermarket product. You can buy 6-packs of it everywhere. And that's kind of why I thought it might be interesting for me to do a talk on it. Right, so we'll crack into some of the basic compounds that we're going to be talking about here, polyfunctional thiols and terpenes, mostly terpene alcohols. Again, there will not be a test later. You don't have to remember the compounds themselves. But for example, here are a couple of sensory active compounds in each group. For instance, again, the grapefruit and sort of floral lavender particularly. So what are the basic components that we need for biotransformation? The first one, obviously, you can't have biotransformation without the bio part, which is yeast. So biotransformation for yeast has a biological imperative that is not related to sensory, right? I mean, the yeast don't care if our beer smells better or tastes better. They're trying to get something out of it. So I'll mention this a little bit later. It's, you know, it's an interest, and it's good to know why the yeast is sort of doing these things for the timing of some of your hop additions. Speak louder. So, biological imperative, and freeing of sensory active compounds from a non-sensory active precursor is sort of key in this whole topic as well. And so the freeing of these sensory active compounds is done by enzymes produced by yeast. And there are a couple of principal ones that we're going to be discussing over the course of this talk. Beta-glucosidase and beta-lyase. And you can see, for instance, this is our Lallemand Premium range. Don't worry, it will be blown up so you can actually see it later. But as you can see, this shows how much variation there is in expression of these enzymes just genetically, different types of yeast. And so the yeast is a really significant component in building your recipes and getting the most out of the hop compounds you're adding. Obviously hops, also very important. Now hops, as you're all somewhat familiar with, green flowers, they have a number of constituents. The bit that we're interested in is kind of by weight, easily the smallest, which is the essential oils fraction. Varies hugely in hops depending on hop variety, the location of where it's been grown, even the year. There's seasonal differences as well. And so I would always urge you, wrong order. And so the bits that we're actually interested in for the purpose of this talk, there are sort of three main fractions. This is drilling down within the essential oils component, the hop oils. We have a hydrocarbon fraction, an oxygenated hydrocarbon fraction, and a sulfur fraction. Now, the only bits we're really interested in today will be these two here, handily highlighted in big red boxes. The regular hydrocarbon fraction tends to be compounds like myrcene, which is, if you've ever had maybe an IPA with very high myrcene hops, it's very resinous. Pine maybe, but yeah, very green, almost like smelling the smell of the hop pellets themselves. And that's not necessarily something we want. It is a component, but we're more interested in these smaller components, which tend to have floral, fruity characters, which really boost that perception of juiciness. So, very important to get this across at this point. These terpene alcohols and the sulfur compounds, these polyfunctional thiols, that's where they fit. They can be present in hops in both free and bound forms. So if they're present in a free form, it's already sensory active. That's why many hops are very sensory active when you add them very late in the dry hop process. They're still super fruity. That's a free form. And there are also bound forms for both of these. And bound forms are sensory inactive before we combine the right combination of yeast and hopping activity to free them up and make them sensory active. So this is, as you can see already, like what we're interested in is better utilization of what's already in those hops and building recipes around that. Just as an aside, again, as an ex-brewer, I'm always interested in what you're actually buying, right? So for instance, I don't know how well you can see this, but two different cascades grown in different places. There's a New Zealand grown one, because I have a New Zealand bias, I'm from there. You can see the oil content, which is a really good indicator of potential aromatic intensity. And we're up just over 2 mils per 100, 2 mils per 100 grams. And then a different hop company has a much wider range, for instance, for their essential oils of sort of 0.8 to 2 mils per 100 grams. So as you can see, if you're buying, 1 kilogram of this and 1 kilogram at the lower end of the other one are not exactly the same things. So it's always important to, when you're concentrating on creating these aromatic beers, make sure you're keeping an eye on COAs. And finally, malt. Malt does have some contribution to the total precursor pool. It's less well understood than hops because it's currently thought that the total contribution is an order of magnitude smaller. That being said, the research is very new on this, and I think there'll probably be a lot more interesting things to be done from maltsters around this too. Now, it is definitely identified as a contributor, though. So it's been found that basically like base malt contributes, I believe, the most thiol precursor. And even in a recent study, malt-based wort produced more free thiols when analyzed than a non-malt-based, like synthetic wort, essentially. All right, so moving into terpenes. Back to the sort of, again, as you can see, the further we get into it, the more complicated everything gets, but it's not too bad. All we're really looking at here, there are obviously different groups. We have myrcene in the regular the regular terpene group. Then we have oxygenated terpenes, which tend to be our terpene alcohols. They're kind of what we're interested in. And there are also esterified versions of the terpene alcohols as well, which I'm not going to talk too much about. I mean, the esterified terpenes are certainly a contributor, but yeah, I've kept it slightly simpler. So, terpene, all right, everyone buckle in with me. It'll be a small amount of biochemistry. Terpene precursors from hops are typically as glycosylated monoterpene alcohols. What does it mean? Diagram. Glycosylated is attached to a sugar. Okay, so you've got a little sugar down here. And that's attached to a aromatic terpene compound, linalool in this case. And this compound, as it is here, is not aromatic. It's the glucose is attached, so the plant can more easily move that glucose around the plant. Okay, so what yeast can do is produce an beta-glucosidase. Exo being it excretes it from the cell into the wort to act on these compounds. And that enzyme cleaves the bond by hydrolysis, frees up simple sugar, which is the biological imperative. That's what the yeast is actually interested in, is glucose. But then it also will free up linalool for us, which is highly aromatic. So terpenes are also interesting in that there is interconversion between different types as well. And this is also frequently mediated by yeast. So this doesn't mean too much yet. We're about to get to a table which sort of describes a few of these compounds. But as you can see, you've got draniol and nerol, which are present in a raw state, both as free and bound. They can transform into things such as beta-citranolol, okay? And beta-citranolol is very lemon, lime, very sensory active, very pleasant as well. Draniol and nerol are very like rose water, which we'll get to in a second. But the main thing here is that citranolol can only be produced by yeast. So if you just add hops and don't ferment, you'll have draniol, you'll have nerol, you'll have linalool, but you won't have either of these other two here. So, diagram to try to show this. So you can see there's sort of two main things we're looking at here with the terpenes. We're looking at freeing of precursors, and we're looking at transformation within the terpene alcohol family. You see a little draniol turning into a citranolol up there. And so what this is showing, we're just going back to, does that work? Anyway, we're going back to the terpene alcohol transformation. And so the purpose of this is there's 3 hop varieties on the left and 3 on the right. The purpose of this is to show that as fermentation basically goes on, so these are concentrations of terpene alcohols in the wort going through fermentation and actually into the beer at the end. And the bottom and top are respectively linalool and draniol, which are present in the raw hop compounds and as precursors. Beta-citranolol, as you can see, is basically being converted during fermentation. So that increases during fermentation. The others decrease to different levels depending on how much bound versus free they had at the start. The other thing that's probably important to highlight is just the degree of magnitude difference in the initial concentrations, right? So here you've got, for instance, Cascade, and it's all the way down at sort of, very low levels of linalool relative to others, and then you come across something like Citra, and it's much higher. So, 4 times the amount. So it does make a huge difference as to how you pick your hop varieties. So here's a table just sort of summarizing some of these compounds that we're interested in this family, and geraniol and nerol are isomers, so they're slightly different sensory activity, but as you can see, still very sensory active. They're floral, they're fruity. Obviously citronella, we have the citrusy character, lilac flower, lavender flower. And I guess to give you some perspective, the sensory threshold for something like acetaldehyde, the green apple fault in beer, is 10,000 to 20,000 micrograms per liter. These are sensory active at, 7. So very sensory active. These are why these compounds are significant in beer, especially hoppy styles. And the other thing that I think is really important to get across, because we live in the real world, not in a science lab, so these compounds are always going to be interacting with other compounds, and we need to think about that as brewers too. So for instance, there's synergistic effects with other fruity compounds. For instance, lactones, which can be peachy, apricotty. Our strains, New England and Verdant, both produce sort of really lovely, delicate apricot peach ester. Lactone. That actually will interact with some of these fruity characters to boost their perception. That's why, for instance, the Verdant IPA strain is super popular for hazy IPAs in New Zealand for that reason. It's a synergistic effect. And thiols, obviously, which we're going to get to in a second, also extremely fruity compounds. They tend towards more tropical than floral. And altogether, these things can create an overall impression that's stronger than the sum of the parts. You can also it's also been studied that you can have bitterness, the perception of bitterness affected by concentrations of something like geraniol, and it can actually smooth bitterness and provide a sweeter impression. Okay, text again. Terpenes, increasing concentrations. How would you go about it practically, right? So you can use high precursor or high free terpene alcohol concentration hops, okay? So if you're using high precursor, you want to make sure they're in the process early so that the yeast can transform them, and you need to choose a biotransformative yeast. So just some examples are Bravo, Citra Mosaic. Bravo, for instance, that was one of the ones back on the graph which had very high levels of some terpenes. And so those have to be, and you can obviously add hops later which are high in non-bound terpenes as well. For instance, Motueka, Chinook, and also Citra. So it's really about targeting what you want out of it. So you can do both as well, obviously. You can have an early dry hop, or you can load up your whirlpool with lots of hops with bound precursors for biotransformation to take effect on. Or you can do that, and then you can also add dry hops later on in the process that have a higher percentage of free, therefore potentially getting more of these compounds into the final beer. Obviously, choosing a high glycosidase activity yeast strain is key. You can put all the precursors you want in there. If the yeast isn't converting any of them, you won't get anything, or you'll get very little. And timing of hop additions, it's important. That's why a lot of the literature around these styles suggests a split dry hop with a first dry hop actually going in during fermentation. The reason for that is exactly what we've been talking about. It's to get that biotransformation activity to occur when you actually have active yeast in the fermentation. If you don't have active yeast, you're not going to get biotransformation. So dry hopping cold at the end, that's great. You'll get whatever terpene and thiol profile is free in the hop, but you won't necessarily get any actual of this extra activity. As you can see, slightly larger graph this time. We've got a number of strains which we've tested fairly high for beta-glucosidase activity, sort of BRY97, our American ale strain, Kolsch strain, it's quite popular. One or two brewers in New Zealand use that as a house strain, and they'll use it for hazy IPAs, and they'll use it for lagers as well. and also New England, and actually, to be honest, Verdant as well, again, but it's more of a synergistic effect with Verdant too. So while it does free some glycosides, it also has that sort of lovely lactone character, which will complement these terpenes. I haven't talked about Bell Saison because I haven't met that many people that make Saisons in New Zealand, but you could feasibly make a hoppy Saison with Bell Saison and still expect to get some of that really nice biotransformed character. Some of the other things you can look at, we have a product called, from AB Vickers called Aromazyme. This is an exogenous enzyme. It does a lot of the same work as what yeast beta-glucosidase would do, except it's a powder. You can add it into the fermenter to act on those precursor compounds. And just as a side note, which we're just looking at quantifying at the moment, but we've also found it will release, if added in the mash, it will actually release ferulic acid to some extent too, which will, for like wheat beers, you'll get higher 4VG, potentially higher 4VG in your final beer, the clove character. And so that's an interesting product. And the question, obviously, you're probably all asking right now, when I've just been talking about yeast, is why would you use an exogenous enzyme, right? Fair enough, good question. Gives you the possibility of, well, there's a few things. It's more efficient at freeing terpenes, but also you can pair it with a yeast that's not naturally high in terpene freeing ability. So for instance, if you've got a yeast with a really complementary ester profile and you think biotransformation character would go really nicely with it, you could use exogenous enzyme and combine those two things to create a more unique product. The other thing I like talking about, again, my days as a brewer as well, but you can target specific terpene production, right? You can add lots and lots of geraniol heavy hops to your, later on in the, for instance, late hopping, so whirlpool hopping, cold whirlpool hopping, early dry hop, and as long as that's all present in the wort at the start of fermentation, you can expect plenty of that conversion into beta-citronellol. So it's, I like talking about citronellol because one of our native New Zealand hop varieties is a hop called Motueka, very high in geraniol. So we have like an entire style called New Zealand Pilsner, and it's almost characterized by really high levels of that citronellol. Like I always sort of, it's kind of my litmus test for a really nice one. And I mean, this might interest some of you as well, but coriander seed, it's also extremely high in terpene alcohols. It's nearly identical terpene alcohol profile to something like citra hops. So it gives you a really interesting way to experiment with boosting that character. You could use a small amount of coriander seed just like you do in a wit beer, in a hoppy pale ale or IPA, to further increase that base terpene profile. Challenges, there are always challenges. Everything we do. One of the big ones is that glucosidase is repressed by glucose. So at the very start of fermentation, before your yeast has had time to chomp up all the glucose, which that's the preferentially consumed sugar, you won't have any great enzyme activity until that's done. Luckily, glucose is a very small proportion in wort. Of course, if you're adding something like dextrose in the kettle and you have a higher starting concentration, maybe that will significantly delay. Timing of hop additions can affect other things. If you're trying to make a hazy IPA, you would like it to be hazy usually, especially if you've already made the labels. Gets you in trouble. And sometimes mistiming a dry hop or an early dry hop can actually lead to increased flocculation rather than less, or I should say, decreased haze stability. And terpenes, as you can see, they're volatile. We want them to be volatile. That's what's, when we pour the beer, that's what's coming out in the aroma, volatile terpenes. So the question then as well is, if we're forming them very early on in the process, is the action of fermentation actually going to be scrubbing those compounds? It's a good question. And then I guess you just add more, or, you know. There are other tricks as well, which I'll get into a little bit later. How is everyone going? Everyone's still awake, that's good. And any questions at this point? I'm happy to field now, or we can save them to the end. If you've got anything that's gonna like fall back out of your head, because I'm about to go into more stuff. Okay for now? All right, keep going. Okay, thiols. Right, polyfunctional thiols. Very, very hot right now. Why? Well, they are a very aromatic and very low concentration group of compounds in beer. And they also give a lot of tropical fruit character. And people love tropical fruit, so why not, right? And I think you probably need to get a better scale of this, but we talked earlier about essential oils being, the oil component of the hop being 0.5 to 4% by weight. Okay, of that 0.5 to 4%, this is then less than 1%. And then that includes other sulfur compounds, some of which are undesirable. So as you can see, very, very small fraction. Why it matters is the sensory activity, which we'll get to in a second. And as with terpene alcohols, these exist in both free and bound forms in hops. Okay, so, if you don't want more of it transformed, you can always buy hops with lots of free thiols, but they tend to be expensive. And so, yeah, and we'll get to the freeing mechanism in a second. Now, the other thing that's important to know is that the vast majority of, unlike terpene precursors, which a decent amount of which are freed up during fermentation, it's a very inefficient process to free up thiols. It's a fraction of a fraction of a fraction. Like you're getting usually less than 1% conversion of bound thiols into free. But again, it matters because they're so sensory active. Okay, so just like with our terpenes, we have some biochemistry again. Now, unlike terpene alcohols, thiols are bound with amino acids. So specifically, typically cysteine and glutathione, conjugated, bound. And so as you can see, you've got 4-MSP bound to a cysteine, which is no good to us, or it's at least aromatically no good to us. With the action of beta-lyase, which is the principal enzyme involved in this in brewing yeast, it splits out into cysteine and 4-MSP, which is a very volatile thiol. And so as you can see, biological imperative, the yeast gets cysteine. So it gets something to make proteins with. Now, I think the important differentiation to make as well is that this lyase enzyme is an endoenzyme. It happens cytosolically. All that enzyme action is actually happening inside the yeast cell. And again, you can also get esterification, which I believe was talked about yesterday as well. But basically, free enough precursor, as you can see, has to be taken into the cell, and it's excreted as a volatile compound into your wort or beer. And equally, there's esterification of some of these compounds as well, with, as mentioned earlier, 3-MH, which is a sort of grapefruity character being esterified into 3-MHA. And they're actually quite significant thresholds for sensory as well, which we'll get to now, hopefully. 4-MSP as well is kind of like, it has a weird combination of characters. It's kind of like what we call catty hop character, which is not always pleasant, but it can be nice in small quantities. Cool, so these are some of probably the most interesting files. Well, there's obviously more, but pick these out. And these are all able to be, well, with the exception of 3-MHA, which is through esterification, these are able to be freed up during fermentation from bound precursors. And I think the important thing, again, to get across here is just how sensory active we're talking here. So 4-MMP, blackcurrant sort of character, 1.5 nanograms per liter sensory threshold. Or 3-MHA, for instance, 4 nanograms per liter. And when you're talking about the threshold of something like diacetyl, you're at 1 to 200,000 nanograms per liter, and that's threshold. So this is why these are such interesting characters to build into our beer. So increasing concentrations, high precursors, same thing again. You can use high precursor hops, such as Cascade, Saaz. There's been some work done on mash hopping, particularly with Saaz, is what I've read, to free up precursors actually in the mash itself. There are also obviously hops which are high in free thiols as well. And actually just going back to here, again, New Zealand, but Nelson Sauvin is one of our New Zealand hops. And it's very high in 3S4MP, which is kind of this characteristic grapefruity rhubarb. It doesn't really exist in the fruit world, it exists in hops. So it's kind of it's quite a weird one. But it doesn't really, it's usually described as exotic fruits, which is because there's no fruit to match it with. So you can choose hops like that, for instance, to target your thiol profile in a certain direction. Citra, again, jack of all trades. High beta lyase activity yeast strains, which we'll jump to again. And again, timing of hop additions. It's biotransformation. You need to have active yeast to be able to biotransform something. Okay, and again, same graph, but this time looking at the blue lines. Again, BRY97 tests really well for this activity, but particularly verdant IPA. Again, just coming back to a lot of people using that strain, in my market anyway, for hazy IPAs. It's more effective at freeing thiols than other strains in our catalog. And that means you can really create beers with this lovely sort of fruit juice, tropical fruit juice character. Also, Lallemand Brewing Wit actually tests really highly as well. And I mean, I don't know if anyone here brews crossover styles, but you can make hoppy wit beers as well. Keep bitterness very low, and look at dry hopping maybe during active fermentation to try to promote some of that lyase activity, just to sort of broaden and make a new style, if you will. Okay. Again, there are similar things you can do. You can target specific thiol production. You can add lots of 3MH hops to the wort stream or an early dry hop to try to get esterification into that 3MHA, that passion fruit character. There are also synergistic effects. Again, coming back to that, for instance, a study showed that synergistic effects between 4-MMP and sort of geraniol, linalool, citronellol raises the overall perception of tropical fruit, even though those terpenes themselves are not overly fruity. And 4-MMP is blackcurrant rather than tropical, but that was what was found. And there are always new products coming on the market. For instance, people are now selling New Zealand's grape skin extract as a powdered form. It's a product there, Phantasm, which basically is just loaded with precursors. So rather than only using hops, you can use a combination of things. You can use fruits. There's plenty of fruit. Passion fruit powder or passion fruit, high in thiols as well. So one of the big challenges I sort of already alluded to, but for biotransformation of thiols to take place, it has to take the precursor into the cell itself. And that's kind of one of the key issues, is that then you've got a whole bunch of other metabolic processes that need to take place. That needs to be accepted in through the cell wall, and it needs to be brought into the right part of the cell for that biotransformation to take place. The other interesting one that we run into in beer particularly, I guess I should say that thiol expression is a very well-studied area in the wine world. Like, they've been studying that for a long time, especially my home country. A lot of our wines are thiol-driven. So a lot of research was going on sort of in the early 2000s in this area. What we found so far is that it doesn't work the same in beer. And one of the reasons why is very likely that our wort's probably higher in nitrogen, and there is repression of the main gene involved in expressing the lyase enzyme. It's repressed by nitrogen. So, for instance, a recent study showed that if you increase the amino acids, it negatively correlates to thiol release. Makes sense. Yeah, an additional complication is that, as you can see, they're very sensory active at very low concentrations. So measuring them is a real pain. Precursors are very difficult to measure. The actual thiols themselves are also difficult and expensive to measure. We have there's analytical capacity in New Zealand for this, but there tends to be a lot of variance in the methods. The methods change. It's hard to do. So the other issue, and this is why obviously you can see different expression amounts of the lyase enzyme, is there are IRC7 gene, you'll hear bandied about, and if you do some American podcasts and stuff, people love talking about IRC7. That's the gene that codes for the main beta lyase enzyme. It's a complicated gene because it can be in different lengths, it can be in multiple places on the genome, and yeah, so it varies hugely depending on the strain, as you can sort of see in what we showed you before. And one solution can be GMO to basically overexpress the enzyme. I think the jury's probably still out on how much thiol you actually want in a final beer, whether an overexpressed overexpressed expression of this will actually make good beer. And a final end note of one of the other studies too, was that it appeared that thiol expression was negatively correlated with pH increase as well. So I think lower pH, closer to 4, showed slightly more expression. That wasn't the primary area of the study, so probably an early conclusion. So speaking of conclusions, obviously, as you can see, lots of complexity. We, as brewers, you need to carefully select hops and yeast to get the most out of both. And especially when building recipes, start playing around with these concepts. Start trying to think about what you want to create in the final beer, and then targeting these combinations of ingredients to get that. Well, I do actually have a real example in a moment that I made. And timing and quantity of hop additions. Always remember that too. If you're freeing precursors, you need active yeast. The other thing is these compounds are very volatile. Okay, and you need to always remember in the rest of your brewing process that you can convert all the precursors and still volatilize all of it out of the sidearm of your fermenter. So think about other ways to minimize volatile loss. You know, we can tell you as yeast manufacturers to just use the right yeast and use lots more hops and all this, but if you're then just off-gassing it all through poor carbonation technique, for instance, or very warm fermentations where you're having greater volatilization. So this is an area where you can look at spunding, natural carbonation. I'm not sure exactly how carbonation is typically done here, but back home we would use carbonation stones, sintered stones. It's a very harsh way to carbonate because if you have these very volatile compounds, you might lose them in that process. Okay, all right. Everyone's still with me. I'm nearly done, I swear. And put it into practice for you all. I thought this might be an interesting way to end. Here's an example of a tropical pale ale, which we're going to ferment with Verdant IPA. Let's put some of these things into practice for you. Okay, we'll start off with a nice little 5% pale ale, something that would be consumed by many patrons, aiming for low bitterness, but enough to balance the juicy perception of both terpene and thiols. Okay, we're going to go 100% pale lager malt. In theory, boosting thiol precursors. We're going to mash hop with SARTs. Again, increasing thiol precursors. Bittering to 20 IBUs with a neutral hop variety earlier on in the boil, and then using a cool whirlpool, so trying to decrease the amount of loss from the hot side. It's a pretty common technique for hazy IPAs back home. Basically then your whirlpool addition or your late hop additions are less likely to lose some of their potential. I'm using grams per liter, hopefully that's okay. So I'm going to whirlpool hop with 6 grams per liter, a combination of Sauvin, Bravo, and Cascade. The reason being, Nelson Sauvin from New Zealand, but it has this unique thiol character, both in free and precursor forms. That will start to layer up some of this tropical fruit, white grape character. Bravo, not commonly used hop necessarily, but tests really highly for free and bound terpenes. And then Cascade, trusty Cascade, which has, again, an abundance of thiol precursor, particularly 3MH, which is that sort of grapefruit character, which can be esterified into passion fruit. Ferment it 1920 with Verdant, and split the dry hop as well. So we'll go for an early and a late dry hop at sort of 15-20% attenuation when we're sort of starting to get nearer to peak cell mass. Throw in a little 3 gram per liter mixture of Nelson Sauvin and Cascade. We've got precursors in both of those, particularly the Cascade. We want to push as much of that passion fruit character out of the Cascade as we can. So we're going to add it nice and early. Then later on for the final dry hop, where there's still a little bit of yeast activity, but right at the very end, throw a nice 3 gram per liter of Citra in there as well. Citra is really high in free thiols as well as free terpenes. So we're going to minimize the volatilizing of the free thiols that it's got and try to retain them in the final beer, then spund it and naturally carbonate it. And yeah, that's my tropical pale ale. And I haven't actually brewed it, but I thought the picture was quite nice. And if you want more information, we've got, Lallemmand's really good at making some resources. The lovely Sylvie has some resources over there. Oh wait, sorry, might be Shrikant, our distributor here. We have some resources at our stand as well. some nice little takeaways if you want more information. It's similar information to what I presented in Biotransformation. We also have some IPA solutions, which sort of details a lot of the techniques and products that people would use in IPAs as well. Not to mention our blog on our website is really active. Just last month, I believe, we just put up a big newsletter, which has a huge section on biotransformation by brewing yeast, and it's actually written by a couple of actual hop scientists. So it's also got some further really good information. So I recommend you check that out as well. And some references, and thank you. And could I get some questions, please? Silence.
So if I want to maximize the thiols and the terpene alcohols, can I blend BR197 and Verdant both together and do the mash hopping in Whirlpool and the dry hops?
Yep, very, very good question. Can you maximize, for instance, for yeast varieties which are high in beta-glucosidase but not in lyase and vice versa, can you just blend yeasts to get the most out of them? Absolutely. I mean, we don't have too much trial data on it, but there's absolutely no reason that wouldn't work. And it's definitely something I'm interested in sort of getting brewers to play around with a bit more back home. I think there's a lot of scope in blending. Obviously with dried yeast, it's extremely easy because you know exactly what proportions you can be adding. You can tweak those proportions and you're always going to get the same result. So I think it's really fertile ground for playing around with that sort of thing. Yeah.
I'll do it and let you guys know.
Yeah, thanks. Anyone else? Have I silenced you all? Good. Okay.
Hi, my name is Chinsi. Sorry, quick question on the use of, I noticed, there's grape skins and Phantasm, and there's, it's particularly Nelson Sauvin from New Zealand is what I believe is being sold as the Phantasm extract. Is there anything about any other grape varietals or, something alternative to that particular strain?
There probably is. Yeah. That's a very recent product on the market, and I think they picked, basically just picked a grape style that's very popular in New Zealand. A grape variety that's grown a lot, that they already know has a thiol profile, and it's already quite well researched. I think you're absolutely right. I think there's probably there's many other varieties which will also have plenty of precursor and free thiol and skins and maybe in juice as well. I mean, again, back to my wine background, but there are some grape varieties which are known for their terpene profile, like Gewürztraminer from Germany. It's very heavily terpene forward, the juice. So I'm sure there's plenty of interesting things to be done there.
Thank you.
So I have a question. How do we analytically measure the changes that are there after addition of all this? Or is it all based on perception of taste? Or only understood by sensory?
Yeah, it's a good question. Like I sort of alluded to, its analytical capacity for analyzing specifically thiols is limited because it's challenging. Very, very low concentrations. I think a lot of this field, look, there's more and more going on. There's a lot of new research coming through, but you're correct in that I think a lot of, well, no, there's definitely plenty of analytical work being done too, but a lot of what brewers in New Zealand would be doing would be sensory. Yeah.
Because there is a lot of bias in sensory. One person could have a different perspective, the other could have another. So if we were to give a proof of things, then it's a little difficult through sensory.
Maybe, but I mean, you're talking about highly sensory active compounds. I mean, a lot more so, particularly in the case of thiols. I mean, I agree there's always going to be sensory bias, absolutely, but if you're talking about building a new brand, you're using those sensory markers as a brand marker, right? So I mean, if you want it to be more passion fruit forward, then you do your best in the process and see if it comes through in sensory. If it doesn't, tweak the process, try again until you see what you want, or look for other ideas. Does that kind of answer your question?
Yeah, kind of.
Okay, looks like it. I'll be around anyway, so feel free to come up and have, oh.
Do you see a future with genetically modified yeast strains where they could at one point maybe potentially just eliminate dry hopping if they could naturally produce those congeners?
It's a big question. I guess the first part of it is for Lallemand, we do have some GMO strains available in the States. Well, our main one that's released currently is like a Saccharomyces cerevisiae with basically a clean ale strain with an acid production gene. So you can sour while you primary ferment. And there's certainly a lot of scope in it, but we've been focusing a lot more on hybridization, which is a more natural method and basically doesn't have trade barriers, essentially, which is the biggest thing. I mean, we're a global company. We're trying to provide yeast all around the world. In some markets, they will be a long road to them accepting GMO. The second part of your question, it's a good question. It's can we completely replace hops in the brewing process by overexpressing or creating de novo expression of some of these really highly aromatic compounds? Maybe. I mean, I think if anything, probably what I've shown is that a lot of these compounds work together. So unless you're able to create a strain which produces a lot of these compounds together, you probably find it to be quite one-dimensional. And we've got a sensory sort of session later on today where we'll actually have a couple of hop compound isolates. So you can see what geraniol is like on its own, which is to say it's not that great.
Scott, was there a fan threshold for maximum thiol expression? If you go beyond a certain number.
Sorry, I missed the start.
Sorry, I was saying, was there a nitrogen threshold?
The research is underway. It'll be different for every strain as well, because as you know, all brewers used to have slightly different requirements. And I think it will end up being that as yeast suppliers, we'll need to do more research into specific strains that already show potential to try to work out exactly what the best advice is around that. I mean, obviously, if you're trying to artificially lower fan by use of adjuncts or something like that to increase lyase activity, you then pose issues with fermentation quality. So I think that's why it's a particularly interesting topic. So in short, I don't have a good answer for you.
No, did you measure your fan numbers when you brewed your pale ale?
No. All right, thank you all very much.
Could I request you to stay on stage, please? We'd really like to give you an award for participating and being a speaker with us.